So, do you remember from 9th standard, we studied a formula called Heron's formula? Yes? To calculate the area of the triangle. Okay. In that, whenever we had a triangle ABC, the side opposite to the angle A was, it was written as small a, right? If this is capital A, the angle is capital A, this is small a, small b, and small c. Okay. So, the area of the triangle was given by, what was it? Yeah. S minus A into S minus C. Okay. Now we'll learn some more properties. Now that we know trigonometry, at that class we didn't know that. But now we'll relate these A, B, C, the length of the sides, with some trigonometric ratios. Like first, we'll do the sines rule, which is the relation between the sides and the sines of these angles. So indirectly, this is a relation between the angles and the sides. So do you all know the sines rule? Anyone? What? Yeah, exactly. So sine of angle A upon small a is equal to sine of angle B upon small b, sine of angle C upon small c. Okay. So in this case, if you know, let's suppose these two things, okay, this side B and this angle B, and you know the side A, then you can easily calculate the angle A, and similarly the angle C. So this is very helpful. So write down the sines rule, and since they are all equal, they can be put as some constant k. Okay. So sines rule will be sine A upon A, sine B upon B, sine C upon C. They are all equal. Now let's suppose in this triangle, small a is equal to 4, small b is equal to 12, and angle B is equal to 60 degrees. Can you calculate the value of sine A? It's a very simple question. So simple application of sines rule. Similarly, you have A is equal to 2, B is equal to 3, and sine A is equal to 2 by 3. Find angle C. Or maybe just find angle B. So the sine rule says that sine A upon small a is equal to sine B upon small b is equal to sine C upon small c. Done? What's the answer for first one? Huh? Root 3 by 6. Okay. 1 by 2 root 3. They're the same. Okay. And the second one? 90 degree. Okay. Done? Both of these. Write one more. A is equal to 75 degrees. B is equal to 45 degrees. Find the value of B plus C root 2. And the options are so those of you who have come late, just see that we discussed that this you know what is small a in a triangle? What is it? Yeah. So if we have this angle A, the side opposite to the angle A will be small a. So therefore we have the sine rule, sine A upon small a is equal to sine B upon small b is equal to sine C upon small c. Okay. So we just have to apply these things in these questions. In the first one we have the side A, okay, the angle B and the side B. So therefore sine A upon small a, sine B upon small b. Okay. So what is sine of B? First of all, let's write down the value of side is 4. Then we have sine of B, which is sine 60 root 3 by 2. Okay. And then you have B, which is 12. Okay. So value of sine A is equal to root 3 by 2 into 4 upon 12, right? So this is root 3 by 6. So this is the answer. Similarly, second and third. Have you done the third? What is the answer? So answer for the first one is root 3 by 6. Second one, sine A upon small a is equal to sine B upon small b. So 2 by 3 upon 2 is equal to sine B upon 3. Everything cancels out. So you get sine of B is equal to 1. So B is equal to pi by 2, 90 degrees. Okay. You know the value of sine A, you know the value of sine, you don't know the value of sine B. You know the value of side A and side B. Okay. Just apply the sine formula for A and B. Have you written down the first two? Yes? 2a. Got it? So we have sine A upon small a, sine B, small b, sine C, small c. So angle A is 75, angle B is 45. By angle sum property we get angle C which is 60 degrees, because the sum of all three angles is equal to 180 degrees. We know these two, we find the third one. So sine A will be, what is the value of sine 75? Root 3 plus 1 upon 2 root 2. Okay. So sine 75, this can be solved by sine 45 plus 30. And this is equal to root 3 plus 1, 2 root 2. And let's suppose these all are equal to k. Did you assume that these are equal to k? Or without that? Without it. Okay. So this is root 3 plus 1 upon 2 root 2. A is equal to, what is the value of sine B? This is 1 by root 2. B and sine C is? Okay. So if we, now you can see in the answer, we are getting terms only in terms of A, right? So let's try to convert B in terms of A, C in terms of A. Okay. What is B in terms of A? Just compare these two. Yeah. 2a by root 3 plus 1. So by comparing these two, I get B is equal to 2a root 3 plus 1. And if we rationalize this, okay, 2a upon root 3 plus 1. And while calculating the value of C, compare this one with this. Okay, so value of C is you got this? Just write the formula sine A by A is equal to sine B by B, sine C by C. Then you calculate the value of small b, small c in terms of A. Okay, and they come out to be like this. Now you calculate the value of b plus c root 2, and this is equal to 2a upon root 3 plus 1 plus root 6a into upon root 3 plus 1. Okay. So what is this term? 2 root 3. Okay. So 2a upon root 3 plus 1 plus 2 root 3a upon, so you take 2a common, you get root 3 plus 1 upon, so you get the answer 2a. Okay. So B option is correct. Written? So first we had sine rule. So we have all three trigonometric ratios rule. We have sines rule, then we have cos rule or cosines rule, and then we have tan rule. Okay. So sine rule you understand? Sine A by A is equal to sine B by B, sine C by C. Now let's discuss cosine rule. Anybody who knows that? So upon 2bc. Okay. So let's suppose we want to find the cosine of angle A. So this is B, this is C, and this one is A. So I think this thing you also you have studied in physics also, if you remember. In the case of resultant of vectors, you remember? In resultant of vectors we had A vector is equal to B vector plus C vector. Then mod A will be equal to B square plus C square 2bc cos theta, something like that. Remember? Okay. By using this only, we get the cosine formula. So we get cosine of A is equal to B square plus C square minus A square upon 2bc. So simply what you need to do is, you take the adjacent sides of the angle. This is the angle. This is squeezed in between these two sides. You take the squares of these two, subtract the square of the opposite side upon 2 times the product of the adjacent sides. Okay. So B square plus C square minus A square upon 2bc. Similarly, if you want to calculate cos B will be equal to A square plus C square minus B square upon 2ac. Yes, it's sine A upon A. No, it's not capital A, it's sine A upon small a, where A is the angle and small a is the side opposite to the angle. So that's what we mean by sine A by A. Okay. And similarly write cos C. This is A square. So this is the angle C. So A square plus B square minus C square upon 2ab. Understand? Okay. So these are the cosine rule. So if you have A2, B3, C4, can you calculate cos A? Simple. Do it. Meanwhile, I'll give you the next question. It's no. No. 7 by 8. So cos A is B square plus C square minus A square upon 2BC. So this is 3 square plus 4 square minus 2 square upon 2 into 3 into 4. So 25 minus 21 upon 24, 7 by 8. Find the smallest angle of the triangle which sides these. So will you calculate all the angles? Then fix. This is obviously greater than root 24. So this is the smallest side. So let's say this is A, B and C. So what do you want to find then? Just find the value of cos C. Okay, that will give you the smallest angle. So whenever you're given smallest angle or the smallest side, don't calculate all the angles, okay, by applying cosine formula 3 times. Just take an estimate that which side is the smallest one. Okay. Okay, try the next one. Everybody got 30 degrees? So cos C will be equal to A square plus B square minus C square upon 2AB. So this is 6 plus root 12 square plus root 48 square minus root 24 square upon 2 into 6 plus root 12 into, right? So this, so what is this after calculation? 72. 72 plus 12 root 12. This is 12 into 2 root 3, right? So this is, this one is 24, yeah, 72 plus 24 root 3 upon, now this is 4 root 3 into 6 plus 2 root 3. I think these will cancel out, right? So this is 12. So 12 upon 8 root 3, which is actually root 3 by 2. So the value of cos C is equal to root 3 by 2. So therefore angle C is equal to or pi by 6. Try the next one. This is cos square C by 2 plus sin square C by 2. A minus B whole square, A plus B whole square. You have to prove that this is equal to C square. Any luck? Anybody done this?
एंगल के नीचे है 2, पूरे के नीचे नहीं, एंगल के नीचे सिर्फ. हाँ ये ऐसे नहीं होगा ना, ठीक है, मतलब पूरे के नीचे 2 नहीं जाएगा. ओपन द स्क्वायर.
So first step will be open the square, open the identity. A minus B whole square, A plus B whole square. So you just have to open the whole square, you'll automatically get the answer. Open both the squares. Got? Proved? Okay, how many of you? Good. So I think you'll use a bit of trigonometry here. Yes, in the last step. So this is the terms of a square. Collect these terms. You get a square times cos square c by 2 plus sine square c by 2. Collect the terms of b square. You get cos square c by 2 plus sine square c by 2. Collect the terms of ab. So you get minus 2ab cos square c by 2. Okay. So what is cos square c by 2 plus sine square c by 2? 1. Okay. So if I have the angle c by 2 over here, then I will get twice the angle over here. So twice of c by 2 will be, so I get cos c. So this is what I am getting. And what is this is equal to? C square. Okay. How? Yeah. So if we write the value of cos c, we get cos c is equal to a square plus b square. Okay. So this thing will be equal to c square. So there are two ways of remembering the cosine formula. First one is by remembering this formula, or you can remember this thing, that the side square is equal to a square plus b square minus 2ab cos c. Similarly, a square will be equal to b square plus c square minus 2bc cos a. Okay, and so on. Understood? Okay. Try the next question. This question is, in triangle ABC, b plus c upon 11, c plus a upon 12, a plus b upon 13. Prove that cos a upon 7, cos b upon 19, cos c upon 25. Identity. कल दो टॉपिक दिए थे आपने पढ़ाने को, मैथमेटिकल इंडक्शन और मैथमेटिकल रीजनिंग. हाँ ये थे ना कल दो, तो इसमें से ये तो हो गया पूरा, ये आधा हुआ क्योंकि बीच में लास्ट में डाउट्स आ गए थे बच्चों को. वो अपने क्वेश्चन ले आए थे घर से. हाँ? आज तो मैं ये कर देता हूँ, फिर बीच में ये भी रह जाएगा, तो इसको नेक्स्ट टाइम मतलब अलग क्लास नहीं चाहिए इसके लिए. लिख देना कि इट विल बी कवर्ड इन नेक्स्ट क्लास. आज यही करेंगे. So these three sides are the ratios are given. Let's suppose all of these are equal to lambda. So we get these equal to lambda or k. Let's say k. So the value of b plus c will be 11k. C plus a is equal to, okay. How will you calculate the value of a, b and c from here? Can you do it? You have three equations, three variables. Okay. How do you plan of doing it? Yeah. Okay. What we can do is, in such type of equations, we can add all the three equations. What do we get? 2 times a plus b plus c is equal to what? 36k. So therefore a plus b plus c is okay. Now you know the value of b plus c, 11k. So what is a? 7k. The sum of all the three will be equal to 18k. So you just start putting the values of the pairs and you start getting the value of the third side. So if a plus b plus c is equal to 18k, b plus c is 11k, which implies 7k. C plus a is 12k, 6k. Okay, so you get a, b and c. Now can you calculate the value of cos a, cos b, cos c? Right? So just calculate the value of cos a, cos b, cos c and find the ratio of the three. And that will be equal to 7 ratio 19 ratio 25. So leave some space for this and try this at home. Okay, this is very simple. Just have to calculate the value of, what is the value of cos A? No, it will be without k, I think. So cos A is, this is equal to b square plus c square 36k square 25k square 49k square 19 by 31. Okay, 35. Yes. What is cos C? Five by 7. So cos B is 19 by 35. And cos C is 5 by 7. So we get cos A ratio cos B ratio cos C is equal to 1 by 5 ratio okay. If you multiply, yeah, if you take the common LCM as 35, what will you get? 7 by 35, 19 by 35 and 25. So these three are in the ratio 7, 19 and 25. Okay. Understood? So let's move on to the next formula, which is projection formula. So next is projection formula. So in the projection formulae, so let's suppose so these are the three angles A, B and C, three vertices, and this is the side A, this is side B, this is side C. Okay. I want to write the value of A in terms of B and C without including squares. Okay. Then A is written as B cos C plus C cos B. How can you prove this? Upon? Yeah, which is actually C. Okay. And similarly, the value of cos C is equal to upon the hypotenuse. So just apply simple trigonometry over here. Cosine of angle is equal to base upon the hypotenuse. So in this case, the base is this one. In the other case, base is this one. Okay. So side A is equal to actually BD plus CD, which is equal to B cos C plus C cos B. So A is equal to B cos C plus C cos B. Similarly, can you write the two other ones? B will be equal to C cos A plus A cos C. Okay. So we have A is equal to B cos C plus C cos B. B is equal to A cos C plus C. So question is, prove that sine B upon sine C is equal to C minus A cos B. B minus A cos C. Question 2 is, prove that 2A sine square C by 2 plus C sine square A by 2 is equal to A plus C minus B. Please prove it. B square minus C square upon A square. Okay. So there's a question on screen. Let's try these two questions first, then we'll move on to this one. So start from this side. Okay. Okay. क्या हुआ? इसकी वैल्यू पुट की है? नहीं, सी की वैल्यू पुट करो. हाँ? सी की वैल्यू पुट करो ना यहाँ पे. हाँ, ये कट जाएंगे सीधे सीधे, है ना? एक सेकेंड, नीचे भी कॉज ही बचेगा, सी कॉज ही बचेगा. ध्यान से देखो क्या बचा, कैंसिल क्या हो रहा है. लेट क्यों हो गई भाई? minus A cos B upon, what is the value of B? A cos C minus A cos C. Cancel, cancel. These two also cancel. You get this is equal to B by C. You get cos A over here. These two cancel out. You get B upon C. Now you know that sine B by B is equal to sine C by C. So therefore, the value of B by C is equal to, so this is equal to, okay, try this one. So in this case also you need to know the trigonometry, okay, the simple formulae. Sine square theta in terms of 2 theta will be equal to, yeah, so 2 sine square theta is 1 minus cos 2 theta and 2 cos square theta is, So if you have half angles, you have 2 cos square theta by 2 is equal to 1 plus cos theta and 2 sine square 1 minus. Okay. What about A and C there? Which question are they asking about? So sine square C by 2 is 1 minus cos C upon 2 plus 2C 1 minus cos A. So 2 cancel out. You get A plus C minus A cos C plus C cos A. So this is the projection formula actually. This is A cos C plus C cos A. This is equal to B. So therefore this will be equal to A plus C minus, hence proved. Okay. So let's see the question on screen which was asked. So question is B, this is actually B square I think. So B square minus C square upon A square sine 2A plus C square minus A square upon B square sine 2B plus A square minus B square upon C square sine 2C. You have to prove that this is equal to 0. Okay, let's try. NCERT's question. Okay, it shouldn't be a problem. So I think in this one you'll use both sine and cosine formulae. हाँ? क्या? क्या हुआ? अच्छा, ये वाला बोर्ड. अरे yeah, how will you do this? How will you start? हाँ जी NCERT. Very good. cos theta का गया. So I think if we write this as 2 sine A cos A. Let's just solve first one, and symmetry we can similarly write the next other ones. Okay. So we get B square minus C square upon A square into 2 sine A Okay. And side by side, let's write this property that, let's write the sine formula, that sine A by A is equal to sine B by B, sine C by C. And let's say this is equal to some lambda. Okay. So we can take one sine A from here and one A from here, and I can write this as sine A by A is equal to lambda. Okay. So this becomes B square minus C square upon A into 2 sine A upon A, yeah, this is lambda, into cos A. And let's write the formula for cos A, which is B square plus C square minus A square upon 2BC. So this becomes 2 lambda, so this is lambda, upon, yeah, 2 will cancel out actually. So this 2 and this 2 cancel out. And in the denominator we get ABC. Okay. So we get ABC, and here we have B square minus C square, B square plus C square. So this is the final result for the first expression. Okay. Oh, what is this? Next question. Okay, very good. Now can you do it? Now it's become very easy. Okay. So first one will be lambda upon ABC, B square minus C square, B square plus C square minus A square. And lambda, okay, let's write it in the second step. Second one is lambda upon ABC. What will be there? A square plus C square, sorry, A square minus C square, A square plus C square minus this? Where C square minus A square? Where? Okay. Yeah. Plus lambda upon ABC, A square minus B square, okay, and where lambda is equal to sine A by A, sine B by B, sine C by C. So we take lambda upon ABC common, and in this case you can see that we have B square minus C square and B square plus C square. Okay. Similarly, C square minus A square, C square plus A square. तीनों में add हो रहा है. This is getting added. They are all same. According to the sine rule, there are 3 equal quantities. Okay, equal ratios. So lambda upon ABC is common. Now we have B square minus C square, B square plus C square, C square minus A square, C square plus A square, A square minus B square, A square plus B square. So first quantity is B to the power 4 minus C to the power 4 plus C to the power 4 minus A to the power 4 plus A to the power 4 minus B to the power 4. And we have this term left, minus A square into B square minus C square minus B square into C square minus A square minus C square into A square minus B square. Okay, this cancels out. I think this also cancels out. Let's check. 0 into lambda is? Okay. Minus A square B square plus A square C square minus B square C square plus A square B square minus A square C square plus B square C square. Cancel, 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 cancel. So answer is 0. Okay. Yeah. What about the next one? Same NCRT. I think for this one we have to do that tan formula first. Because without tan formula it will be very tough. So this is a cube b cos b minus c, b cube cos c minus a. Yeah, let's do tan formula first. So next is Napier's analogy or the law of tangents. So Napier analogy says that tan b minus c upon 2, this is equal to b minus c, b plus c cot a by 2. Can you prove this thing? Yes. So assume you have to prove this Napier's analogy. What will you do? You'll solve this thing, the RHS, and you'll reach to the LHS. So B can be written as K sine B. Now since sine B upon B is equal to sine C upon C, I can say that B is equal to, let's say this is equal to 1 by K. This can be equal to K, this can be equal to 1 by K, doesn't make any difference. So B will be equal to K sine B, and C is equal, small c is equal to K sine capital C. So this will be sine B minus sine C upon sine B plus sine C cot a by 2. So here we'll apply CD formulae. 2 sine C minus D by 2 cos C plus D by 2, and 2 sine C plus, B plus C by 2, in this case B plus C by 2 sine B minus C by 2. So this becomes 2 tan B minus C by 2 upon tan B plus C by 2 multiplied by cot A by 2. So if you solve, you will get sine B minus C by 2 here and cos B minus C by 2 here. So if you apply the CD formulae, you get 2 sine B minus C by 2 cos B plus C by 2 upon 2 sine B plus C by 2 cos B minus C by 2. So from here you get tan, the tan term, which is tan b minus c by 2. In the denominator you get tan b plus c by 2. Okay, so tan b plus c by 2. Now I can say that b plus c is actually equal to 180 minus a because of the angle sum property. So this will be equal to 2 tan b minus c by 2 upon 2 tan pi minus a by 2 into cot a by 2. So if I split this, if I take separate LCM, I'll get tan pi by 2 minus a by 2, which is cot a by 2. This cancels out, 2 cancel out, I'll get tan b minus c by 2. So this is the proof of Napier's analogy. And similarly in the question which was given, there was cos b minus c, cos a minus b, right? So I guess it will be solved with this one. Written? So you have question 1. Angle A is equal to 30 degrees, B is equal to 2, C is equal to root 3 plus 1. Find C minus B by 2. Question 2 is find tan into cot A minus B by 2. क्वेश्चन खुला हुआ एक ठीक First one is 30 degrees. The second one is easy. Yeah, correct. So first one, tan C minus B by 2. Yes, B and C are angles. So tan C minus B by 2 or tan B minus C by 2 is equal to into cot A by 2. Okay. So this is equal to root 3 plus 1 minus 2. Root 3 plus 1 multiplied by cot 15. Okay. So cot 15 is actually 2 plus root 3. Okay, we write it down your way. Root 3 plus 1 upon. So we get 1 by root 3. Right? So when is tan theta is equal to 1 by root 3? When this is equal to 30 degrees, pi by 6. Pi by 6 is the answer. So now in the second case, this thing is tan A plus B by 2, which is tan pi minus C upon 2 with the angle sum property A plus B will be equal to pi minus C, which is tan pi by 2 minus C by 2, which is cot C by 2. So we need the value of cot C by 2 into cot A minus B by 2. So we know that cot C by 2 is equal to, from this Napier's analogy, we know that tan A minus B by 2 is equal to A minus B upon A plus B cot C by 2. Right? So if you multiply cot C by 2 by cot A minus B by 2, if you write this tan A minus B by 2 is equal to 1 upon cot A minus B by 2. So this will be 1 upon cot a minus b by 2 is equal to a minus b upon a plus b cot c by 2, and you multiply these two, you will get the value a plus b upon, this is the answer. Okay, so answer will be a plus b upon a minus b. Okay, let's see the rest of the half angle formulae. Just write this down fast. Written? So let's suppose in a triangle ABC, you want to find the area of the triangle. Okay, there are plenty of ways, but one way using trigonometry is, if you know all the sides A, B and C, then the area of triangle is written by half AB sine C, and this is equal to half sine A is equal to half. Okay, so if you compare this to your Heron's formula, okay, then sine C can be written as 2 sine C by 2 cos C by 2. Similarly, sine A can be written as 2 sine A by 2 cos A by 2. Similarly for cos B, sorry, sine B. So the formula for sine A by 2 and cos are actually given by this. Sine A by 2 is S minus B into S minus C upon BC, and this is equal to S into S minus A upon BC. So in case of sine, I get these two terms, S minus B, S minus C, all the terms except this A, okay, and in cos A by 2, I get S into S minus A, okay, and if you multiply this, like in this formula, if you multiply sine 2 sine A by 2 cos A by 2, I will get S minus A, S minus B, S minus C root multiplied by, in the denominator I'll get BC, and this BC and this BC cancel out. So I will get the area root S minus A, S minus B, S minus C. Okay. So that's how we get the formula for the area of triangles, the Heron's formula. And if we split this thing, I will get these two parts. Okay. Similarly, I can write tan A by 2. This will be the ratio of these two. Okay. Write it down. So tan A by 2 is okay. So these are very important. These are called half angle formulae. And the area is given by half BC sine A is equal to root S minus A, S minus B, S minus C. So draw this all. Write this down. Done? Okay. Just use this half angle formulae. If A is equal to 13, B is equal to 14, C is equal to 15, find the value of sine A by 2, cos B by 2. Okay, just these two. Find the value of sine A by 2, cos B by 2. What? 1 by root? Okay, the first part. Second part? 7 by root 65. Good. So what is the value of sine A by 2? Root S. Yeah. So what is the value of S here? So sine A is equal to root 21 minus 14, 21 minus 15 upon 14 into 15, 7 into 6, 1 by root 5. For cos b by 2, this will be equal to s into s minus b upon AC. 21 into 21 minus yeah. So this is 7 upon root 65. Okay. So whenever you are asked some half angles, this is the way to find it. Okay. So prove that b minus c upon a cos square a by 2 plus c minus a upon b cos square b by 2 plus a minus b upon c cos square c by 2 is equal to 0. Prove this thing. Are you okay? 0 upon ABC. Okay. So B minus C upon A into what is this? Next term is plus so common LCM ABC from every side. What is this? S will be common. So S upon ABC is common. We get B minus C. And what is the value of S? A plus B plus C by 2. Okay. So S minus A will be equal to minus A. And what is this equal to? B plus C minus A by 2. So you get the sum of B minus C. Let's take 2 also common. B plus C minus A plus C plus A okay, and if you multiply these two terms, you will get B square minus C square in the cyclic order, and they will all cancel out, and similarly these will all cancel out. So this is equal to 0 finally. Okay. So if A is equal to root 2, B is equal to root 3, well, this is a very simple one, let's leave it. Okay, if cos A by A is equal to cos B by B is equal to cos C by C, and side A is equal to 2, 8 delta 2, look delta square. Then find the area of triangle. And also write this question. We have A cos A plus B cos B plus C cos C. We have to prove that this is equal to 8 times delta square upon ABC. First one is done. No? First one is very easy. Yes? Won't take that much time. Yes. Good. Anji, done? First one, yeah, you can either do it by cosine rule. You've done with cosine rule. How? Put this value. Yeah, good. Or you know that sine rule is actually sine b by b is equal to sine c by c. And in this case, we also have that cos a by a, cos b by b, cos c by c. Okay, we know this one already, sine rule, and this one is a cosine rule. If you divide these two, we get tan a is equal to tan b is equal to tan c. Therefore, a is equal to b is equal to c. So in a triangle, if three angles are equal, they are all equal to 60 degrees. So this is an equilateral triangle. Side is given, area is, this is the answer. Root 3 is the answer. Okay. How about the next one? There are plenty of ways of doing this. What should we do? So first way can be if we use the cosine formula for all these three. It can be done with that also. Written this? The previous question. We have a cos a plus okay. We can use cosine rule or the half angle rule. How will you use the half angle rule? How? Hmm? Hmm? So cos A can be written like this: 2 cos square A by 2 minus 1. Understood? Cos to theta. The formula for cos to theta is cos square theta minus sin square theta. So this becomes 2 cos square theta minus 1. So what is the value of cos A? Cos A by 2. Half angle formula. SS minus A upon BC. So this is 2A into S minus A upon B into C minus A. Right? So this will be the value of A cos A. Can this be simplified further? Or let's not. Let's leave it here. Then the next step will be find the value of B cos B. So by the similar pattern I will get this result: 2A upon BC S minus A plus 2B upon AC S minus B plus 2C upon AB S minus C minus A plus B plus C. Right? How am I getting A plus B plus C? Because I'll get minus A over here. In the second term I'll get minus B. Third term I'll get minus C. So by just change A, B and C in all the cases. So what is A plus B plus C? 2 times S. Right? This is 2 times S. So A plus B plus C is actually 2 times S. So therefore I take 2 times S common from everywhere. I get A into S minus A upon BC plus B into S minus B upon AC plus C into S minus C upon right? What should we do next? Open the brackets. We take the LCM ABC because we already need that ABC LCM. So this is 2S upon ABC. This becomes A square, B square, so this is A square plus B square plus C square times S minus A cube plus B cube plus C cube plus ABC upon ABC. When you multiply A square with A, B square with B and C square with C. A square into A is A cube. Okay. Understood till here? Okay. We have to make it 8 delta square. So delta square will look like S minus A, S minus B, S minus C, right? So I have to make this term, okay, this ABC won't be here. So this is what we're getting. So if I write this as 2A plus B plus C, so this is 2S upon ABC I will get 9 terms from here. This is A cube. So I will get 2A cube, 2B cube, 2C cube. And I have A cube, B cube, C cube over here. So I will get A cube plus B cube plus C cube plus A square B plus A square C plus B square A plus B square C plus AC square plus AB square minus ABC. Okay, what to do with this one? I have to make factors of this somehow. Can we make factors of this one? If I had 3 ABC over here, then we would have made, right? This is A plus B plus C whole square अरे यार okay let's take some other way of solving this. We had A cos A plus B cos B plus C cos C. I thought half angle would be easier, but I think this will be longer. Better solve this with cosine's rule. You know cosine rule? This will be B square plus C square minus A square. This is A square plus C square minus B square, and this is A square plus B square minus C square upon 2AC. Okay. So solve it. Or leave this one. This is very clumsy. So by cosine's rule I get A times B square plus C square minus A square upon 2BC, right? And if I take A, if I multiply this by 8 to make the LCM ABC, I get A over here. So I get A square into B square plus C square minus a square upon 2abc. So this whole expression will be a square into b square plus c square minus a square plus b square into a square plus c square minus b square plus c square into a square plus b square minus c square upon 2abc, right? So now you multiply all these. Yes. So what do you get? A square b square, and I get a square b square again. Then you have a square c square again, b square c square, b square c square. So this is 2 times plus 2 times b square c square plus 2 times minus a plus b plus c whole square. No. Yeah, this is getting minus. So now again you have to make factors out of this. You have to take one a plus b plus c common, and the other ones are a plus b minus c, b plus c minus a, and c plus a minus b. So we have to make it 3 factors over here. So what can we do is, first if we make 2 factors, okay, so if I make 2 whole squares over here, so if I collect these 2, so what am I getting? 2a square b square minus a4 minus b4, right, plus 2b square c square plus 2a square c square minus c to the power 4. Right? Now I'll get factors for this. What is this? This is minus of a square plus b square whole square. Sorry, a square minus b square whole square. Can you see this? This is a to the power 4 plus b to the power 4 minus 2a square b square. So this is minus of a square minus b square whole square. And what about this one? You take c square common and you get 2b square plus 2a square minus c square upon 2abc here. Okay, what now? Can you somehow make factors of this? 2b square So just try this at home. Okay, we'll see this next time. What? Well, let's continue with our topic. We have some topics left. So I think what you need to do here is just make whole square over here. This is becoming a whole square. Okay, you need to introduce this form s minus a, s minus b, s minus c, right? Because this is a value of delta square. This is the value of delta square. Okay, and what is the value of s? This is a plus b plus c minus a, and this is 2. So you need to introduce the factors of b plus c minus a and similarly a plus b minus c, and I know all the factors of this. This will factorize to give you this b plus c minus a plus b minus c, a plus c minus b, and a plus b plus c. You just have to figure out how to factorize this. So since this is a degree 4 equation, this will have 4 factors. Okay, these will be the 4 factors. So if you multiply, you get 3 into 3 into 3 into 3, 81 terms. Okay, and then out of 81 terms, I am getting these factors. Okay, so try to figure this out. So let's cover the rest of the things in this chapter. So first, there are two types of circles when we are dealing with triangles. First one is called incircle, and the second one is circumcircle. Okay, so let's see the relation between the areas of the triangles and these radii. So this is small r and this one is capital R. So this is incircle and this is okay. So in this case, the small radius, the in radius will be equal to delta upon s, where delta is the area of triangle and s is the semi-perimeter. And what is the value of capital R? You know it? Value of capital R? So you understand the difference between in radius and circumradius? This is actually joining the center of the circle to this side. Okay, and this is joining this to the vertex. Okay, in circle always touches the sides and this always touches the vertices, and this radius is equal to ABC upon 4 delta, right? So just remember these two formulae. Okay, so if you know A, B and C, you can easily find all these. This one is pretty easy to find. You just need a delta, you just need the area of the triangle, then you can easily find both the radius. Okay. Is this all in NCRT? This thing, in circle and circumcircle, no? So let's take an example. If this is 5, B is 7, and C is, let's say, 9. Can you find both the radii? The small one and the capital one. Do it. So just find the value of delta, just find the area of the triangle, you will solve it. How will you find the area? Heron's formula. Do it. area. And the capital R? So value of delta will be, so first of all, what is the value of S? 21 by 2. 21 by 2 multiplied by 11 by 2 so this again becomes 21, right? And this becomes sorry, so this is 21 by 4 root 11. Okay, so the value of small r, this will be equal to delta upon S. So 21 by 4 root 11 upon 21 by 2. So answer is root 11 by 2. And the value of capital R is equal to ABC upon 4 delta. So this is 5, 7, 9 upon 4 into 15 by root 11. This will be the answer. So small r and capital R, these are the values. Okay. Do you have any questions for these? Your textbooks, Udaan textbooks? Is this chapter in that book? Yeah? No? You haven't checked? Okay, just check it out. If this chapter is there, okay, just try out all the questions and next time bring the doubts. Okay, and try that question. Okay. Okay, thank you.